Welcome to this explainer. We're diving straight into something absolutely crucial for the future of artificial intelligence today. We are going to unpack Snorkel AI's blueprint for evaluating AI agents. Using some really fascinating insights drawn directly from Vincent Chen, a research fellow and co-founder over at Snorkel AI, we're going to explore the art and the science behind how we actually measure these incredibly complex, rapidly advancing models. I know it sounds highly technical at first, but this is literally the secret engine driving the entire AI industry forward right now.
And it all starts with a question we kind of have to ask ourselves. Are AI agents actually ready for the real world? We've all seen the mind-blowing demos, right? Playing around with these agents is incredibly exciting, and it's obvious their capabilities are growing by the minute. But there is a massive, massive gap between testing an agent in a nice, controlled lab environment and actually deploying it safely into the messy, high-stakes real world. And closing that gap is exactly what we're focusing on today. Okay, let's dive into this. Here is our roadmap. First, we'll cover the evaluation gap. Second, the science of benchmarking. Third, the art of benchmarking. And fourth, the next wave of benchmarks.
Starting with Section 1, the evaluation gap, vibes versus high-stakes reality.
Right now, it kind of feels like we are living in a world of pure vibes. Every day we see progress marked by models just constantly hill-climbing on these leaderboards. The coding vibes are improving, and honestly, it feels like a victory every single day. But let's contrast that with high-stakes reality. Try asking a large organization if they're ready to just let these agents loose in, say, finance or healthcare or insurance. There is intense hesitation, and rightfully so. In those environments, it is not just about hitting a neat metric. A mistake has very serious, real-world consequences. Our ability to formally measure these agents is simply falling way behind what they can actually do.
And the urgency to close this evaluation gap is totally real. To put it into perspective, Snorkel AI recently deployed a $3 million open benchmarks grant. They are aggressively funding academic teams and builders just to accelerate the next wave of benchmarks. It's this massive, urgent push to solve the evaluation problem simply because the stakes are just that high.
So this requires a fundamental shift in how we think about this stuff. A benchmark shouldn't just be some snapshot looking backward at what AI has already done. The best open benchmarks are actual measuring sticks that define progress. They set the goalposts for where these capabilities need to go. They literally define the path to getting us to safe and trustworthy agents.
Which brings us to Section 2, the science of benchmarking, building effective measuring sticks.
So the crucial point is, to build an empirical measuring stick that's actually useful, you need 4 foundational pillars. First up is task quality, meaning the tasks themselves must be rigorously validated. Second is distributional diversity. Your testing actually has to represent a real-world taxonomy. Third is model headroom. You have to leave space for models to fail so they can grow. And fourth is robust evaluation methodologies, measuring what actually matters in the real world, way beyond simple accuracy scores.
And this brilliantly illustrates how those 4 scientific pillars map directly to some of the most influential benchmarks we've seen recently. We've got GPQA for quality control, MMLU for taxonomy, ARC-AGI for headroom, and TalBench for constrained adherence. Let's briefly walk through each of these to see exactly why they work so incredibly well.
Let's start with GPQA, which is designed to measure graduate-level knowledge. Its true genius for task quality was actually tucked right away in its appendix. They introduced an adversarial, multi-reviewer protocol complete with specific incentive payouts. Basically, their thinking was, if a task is pushing the absolute frontier of human knowledge, relying on a single expert just isn't enough to verify it. So they used an adversarial, peer-review-style process to ensure the tasks were completely ironclad. Now that is rigorous task quality in action.
Next up is MMLU, which perfectly demonstrates distributional diversity. They went ahead and constructed this incredibly ambitious taxonomy across 57 different academic and professional domains. Now, you might be wondering, why does this matter? Well, think about a self-driving car, yellow lights, or unexpected motorcyclists. Those might be statistically rare compared to driving on a wide-open highway, but they are disproportionately important to get right. A great benchmark intentionally distributes its tasks to make sure those rare, critical failure modes are explicitly tested. Then we have model headroom, which is beautifully demonstrated by ARC-AGI. Look, a benchmark is basically useless if it's completely saturated. When ARC-AGI 3 launched recently, frontier models could solve less than 1% of the tasks, even though they were totally solvable by humans. This intentionally exposes the soft spots in current AI capabilities.
By leaving all this massive headroom, the benchmark can accurately predict and measure huge leaps in progress down the line, like that massive push we've recently seen in advanced AI reasoning.
Finally, we need robust evaluation methodologies. This means moving way beyond simple accuracy. Take a look at TubBench, which evaluates multi-turn agents. It measures task completion, sure, but it also measures adherence to policy constraints. For example, say your AI agent successfully books the correct flight for you, but it completely violates your company's fare class rules to get it done. Well, it completely fails the test. The evaluation actually matches the complex real-world requirement.
Moving on to Section 3, the art of benchmarking, differentiating and pushing the frontier.
But it's not all just rigorous science. There is definitely an art to this, a special sauce that separates good benchmarks from the ones that dictate the entire industry's direction. These frontier-pushing benchmarks have three artistic differentiators. First, they have a bold thesis on where the world is going. Second, they produce roadmaps that spawn entirely new branches of research. And third, they highly prioritize researcher UX.
Let's look at having a thesis. Terminal Bench is a phenomenal example of this. They made a massive, bold bet that the command line interface, the CLI, would eventually become the core, general-purpose affordance for agents to interact with the world. And guess what? They were absolutely right. We are now seeing the teams behind top models like Claude and Codex building general enterprise capabilities directly on top of CLI-based tools. A truly great benchmark predicts the future.
Next is producing roadmaps. SweetBench is just a masterclass in this. They took a relatively simple idea, leveraging existing coding capabilities via pull requests, and it spawned an entire new family of benchmarks. Because of that initial roadmap, we got SweetBench Lite, Verified, Multimodal, and so on. It inspired researchers all over the world to come up with new attacks and new ideas for testing coding agents.
And honestly, this third differentiator, researcher UX, is so wildly underrated. If you want the community to actually adopt your benchmark, it has to be easy to use. Stanford CRFM pioneered this a few years ago with Helm, which was a standardized modular harness. And more recently, Harbor shipped alongside Terminal Bench 2.0, acting as the de facto evaluation infrastructure. Making your benchmark easy to run, easy to extend, and easy to tune against is a core product principle that the very best benchmarks get right.
Let's move to Section 4. Next wave of benchmarks, measuring tomorrow's agents.
So where do we go from here? Well, according to Snorkel AI's perspective, the next great benchmarks need to push reality and realism across three major dimensions: environment complexity, autonomy horizon, and output complexity. Let's break these down, starting with the environment.
Think about environment complexity. The messy reality of day-to-day work is that current benchmarks only capture a tiny fraction of what actually happens in the wild. Think about coding at a real company. Your code base has hyper-specific organizational policies, context scattered all over different Slack channels, completely random screenshots, flaky CI toolchains, and multiple parallel contributors working at once. Future benchmarks absolutely must drop agents into these highly complex, realistic environments to see if they sink or swim.
Then we have the Autonomy Horizon. Right now, we generally test agents on a single, isolated task. But how long can an agent operate reliably before it just breaks down? What happens if it's working on a task for 3 weeks and midstream, there's a massive corporate reorg? Or what if the product specs suddenly change overnight? Future benchmarks need to measure continual learning and long-term autonomy in a dynamic environment, not just test short-term memory. Finally, we have output complexity, which is hugely underexplored right now. We have to move beyond agents just spitting out plain text chat answers. If an agent produces a deeply complex strategic proposal, how do we systematically verify it? We need highly nuanced reward signals that actually capture organizational context. But even more critically, we need benchmarks that measure an agent's own uncertainty. Can the agent recognize when it is completely out of its depth, stop what it's doing, and ask a human for help? Which leaves us with this final, absolutely vital question. How will we measure the trust and uncertainty of tomorrow's fully autonomous agents? The incredible capabilities we're seeing today are thrilling for sure, but without rigorous, creative, and highly scientific benchmarks, they are really just vibes. Thank you so much for joining me for this explainer. Now go keep a close eye on those measuring sticks.